Good morning, welcome back to our channel. In today's we are going to learn how to configure GPIO pins in PIC16F877A. If you are new to our channel, please subscribe and press the bell icon so you never miss our upcoming videos. Let's get started. PIC16F877A microcontroller pin configuration. If you are a beginner in embedded systems, this is one of the first microcontrollers you should understand because it helps you build strong foundation for embedded programming and hardware interfacing. By the end of this video, you will learn pin configuration. Before we start, please subscribe to our channel and press the bell icon so you will never miss our latest videos. Pin configuration. PIC16F877A comes in 40 pin dual line packages. Okay, this is the first line is 20 pins and second line also 20 pins, total 40 pin. Okay, this is the dual line packages, DIL. Okay, here is mentioned for DIL. Okay, dual line packages. It is mentioned for port. The pins are grouped into ports: port A, port B, port C, port D, and port E. Port C, port B, C, D, E also digital pins. Port A is analog pins. Okay, port A is analog pins. Port E is used for digital and analog, but port A also you can useful for digital pins. It is needed for some configurations. Okay, but port C, port B, and port D is no need for external compiler settings. Automatically you can use it for input direction and output direction. Bidirectional is possible. Each port performs input and output operations. Some pins also support ADC, UART, SPI, PWM. Interrupt functions. Okay, B port is supporting for interrupts, C port is supporting for the SPI communication, then I2C communications, then receive interrupt UART communication also is possible. Okay, how to configure GPIO pins? Okay, how to configure to GPIO pins in output direction. 8 LED is on. Okay, my PIC16F8 microcontroller, I want configure to 8 pins is initially on. So this is input, port is output. How to configure this is input, port is output. 1 minute I will show the PIC16F877A datasheet. 1 minute. I opened for PIC16F877A datasheet. You can control F. So this. Otherwise input output you can search. Okay, input. Okay, input is 20 MHz crystal accelerator. Again next here also is mentioning internal. Okay, 5 input channels, 8 input channel, 5 input channels. Okay, you can click it next button. It is showing for how to configure for GPIO pins. This mean what, port mean what. Okay, wait. Otherwise you can type it for directly TRIS. This means this is 85H. File address is address A, address B, address C, address D, and address E. So okay, I will go to directly next. Okay, address A and port A direction register. Okay, address B and port B is data direction register. Address C, port C data direction register. Okay, this is address C. This is both are data direction register only, but which direction, input direction or output direction, how to configure, this is I want need. So I go to datasheet. Again go to clearly datasheet. Okay, port A and address A. Port A is a 6-bit wide bidirectional port. The corresponding data direction register is a address A. Okay, settings here address A bit equal to 1 will make the corresponding port A bin as an input. You can put it in 1 mean it is input direction. Okay, you can keep it in 0 mean it is output direction. Put the corresponding output driver in the high impedance mode. Clearing address A bit 0 will make the corresponding port A pin is output. Okay, example, put the contents the output large, the selected pin. Reading the port A register reads the status of the pins. Various way writing, it will write to port large. All write operations are read modified to write operations. Okay, here address A mean you can set it for 1. Okay, this is input direction. Okay, this means reduce instruction set computing. Okay, this A bit equal to 1 mean it is considered as input direction. You can set it 0 mean it is considered as output direction. Okay, again I go to my PPT slide, my PPT. Here is mentioning for 8 LED on. Okay, 8 LED on mean this is input direction. Okay, this is input direction. You want set input direction mean you can put the value is 1. So microcontroller is understanding for a 0 or 1 binary language. Okay, human understanding for high level language, it is 5 volt or 0 volt. It is human understanding language. But machine understanding language is 0 or 1 binary language. So microcontroller stress is mentioned for input direction mean you can put it for values is 1. Port is output equal to 0. It is initially high or not, high or low. This is mentioned for port. But this is input direction or output direction. You can set it input direction mean 1, output direction mean 0. But port mean it is initially high or initially off. Initially high mean you can put it in 1 or initially low mean you can put it 0. So now this concept is pin number 0 to 7 LED on, other LEDs are off. Okay, here you are using for 8-bit microcontroller, so you can split it for 4 bits. So this value is 8421. So okay, so 2 power 0, here 2 power 0, then 2 power 1. Wait, I will change it to a pencil. Okay, 2 power 1, 2 power 2, 2 power 3. This is the values, resolution values, how to find out. It is 2 power 0, anything power 0, 1, then 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. Okay, 2 into 2. So 2 into 2, 4, 4 into 2, 8. This is I mentioned. Okay, here I want 8 LED on mean every bits also initially high. So 8 bits also 1. So that time I want calculate for all the values. 8421 mean 8421. I mean it is writing for hexadecimal value. Port is mentioned for hexadecimal value. This X is mentioned for hexadecimal value. I want binary value mean it is B. Okay, decimal value mean D. Okay, octal value mean it is O. So here is mentioned for hexadecimal value 0x. So I want mentioned for 0x. So here writing for LSB bit and MSB bit. First you can write it in MSB bit. Second write it for LSB bit. So first I want calculate for MSB bit values. MSB bit also all bits are 1. So I want calculate this value 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. So 9 is 9 after hexadecimal value is 10. Normal decimal value is 10. But here is mentioned for A. Hexadecimal value is A. Okay. 11 mean B. 12 mean C. 13 mean D. 14 mean E. Plus 15 mean F. So I mentioned for 15. So I have written in F. So here also MSB bit. First I mentioned F. Then LSB bit also F. So these 8 pins are I want configure to output initially high. Next configuration I will tell 4 pins is input, 4 pins is output. Okay, you can tell the values. First 4 pin is output direction, 4 LEDs on, 4 LEDs off. So this is input direction equal to 1. Okay, you can set it input direction mean you can write it the value is 1. Port is output direction, you can write it 0. But I want initially high. So pin number 0 to 4, pin number 2, 4, 5, 7 also LED on, other LEDs also off. Okay, here I want tell. So 2, 4, 5, 7. 2 pin number 2 is 1, 4 is 1, then 5 also 1, then 7 also 1. So here I split it in screen. So 4 bit. So here also 4 bit, here also 4 bit, but its value is coming 8 bit value. So here is only 1 bit is LSB bit is bit number 2 only high. So value is 4. This is the LSB bit value. Then MSB bit value is 3 pins is high. So 4, 5, 7. So 4 mean it is 8. 8 plus 2, 10. 10 equal to hexadecimal value A. Then 4th bit also 1. So 11. So 11 means that equivalent value is B. Okay, B here 4. So first you can write it for MSB bit, it is B, then LSB bit 4. Okay, so I mentioned in 0xB4. So initially you can mention port 0xB4 mean it is rightly continuously on, for B4 mean it is high, initially LED is on. Okay. Now clearly understand the concepts of how GPIO configuration. If these explanations helped you understand the concept, please subscribe to our channel and press the bell icon so you never miss our upcoming videos. Thank you for watching this video. If you have any questions, leave them in the comment section. Need help with final projects, any projects or IEEE process, contact and WhatsApp. Don't forget to subscribe and press the bell icon. See you in the next class. Thank you.